Welcome to Waidsum University. Here we are in chapter 5, part 7 of this course. Interconnecting LANs and WANs, interconnecting local area network and wide area network. So we urge you to subscribe to our university YouTube page, for more of our classes to be uploaded in the for you to continue to see some of our lectures on YouTube. So without much ado, let's begin quickly. Now we're saying the introductory part that this section introduces what we call what is known as a LAN. But before we continue, let's bring our highlighter back. Okay, we are doing this before the system went off, and we have to come back again for this. Okay, we say the first part is that we're looking at what we call the local area network. Remember, this section is connecting a LAN and WAN, connecting LANs and WANs together. So we look at the LAN architecture. Okay, and then we look at the data center architecture, and then we look at the WAN technology. Now, this WAN technology includes high-speed serial connections. The WAN technology include the high-speed serial connection and metro optical Ethernet. That are used to connect what? LANs to connect the enterprise network to the outside world. That's what we use them for. We use this metro optical Ethernet or the high-speed serial connections to connect local area networks to connect campus network to the outside world. Is that okay? Okay, that's the first point. Now let's go to the second page. We say that a whole network, the enterprise network or campus network, is made up of three-tiered architecture. And the first one is called the core. The second one is called the distribution layer, the core layer, the distribution layer, and the access layer. Now, the core layer is this first one that we have drawn. This first one is called the core layer. In the core layer, we use what we call the layer 3 switches. We use layer 3 switches or router. You can also use router in this layer. The second segment of the network architecture is called the distribution layer. The distribution layer, usually we use the router, high-end routers to connect, to distribute data packets with the help of IP addresses to various fast Ethernet through the various fast Ethernet port connections to the various destinations. Okay, and then the third layer is called the access layer. The access layer comprises of your local area network, the various local area network in your campus. Is that okay? Now let's move on quickly. Now let's talk about still on the layer 3. Three-tiered architecture. We say that this is incorporated in a campus network. We use this type of connection or breakdown for our campus network or enterprise network, and we do this to improve the data handling and the routing within the network. Okay, we use this three-tiered network structure. We incorporate it in our campus network and also in our enterprise network. The reason being that we want to improve the data handling and the routing within the network. Is that okay? Now you can see with the job we say in the core layer, we use what we call the layer 3 switches, or you can alternatively use routers. And then the distribution layer or the edge layer, the distribution layer or the aggregation layer, we use what we call the routers, or also you can use layer 3 switches. Then in the access layer, we use the layer 2 switches. We use layer 2 to connect our local area networks to our networking devices. Is that okay? Now let's move on quickly. Now let's talk about the first layer, which is the core layer. The core, we say in the core, the network core usually contains the high-end layer 3 switches, which we've talked about, or routers. We've talked about this. Now the core is the heartbeat or the backbone of the entire network architecture. The core is the heartbeat or the backbone, or the central, like the way you say central nervous system, the central or the heartbeat or the backbone of the entire network. Okay, major portion of the network's data traffic passes through the core. That's why we say it's the backbone. major portion of the traffic passes through the core. The high-end routers and layer 3 switches are typical networking devices that are used in the core segment of this 3-tiered architecture. Now let's move on quickly. Now layer 2, let's talk about the layer 2 switches. Well, alternatively, we can use layer 2 switches for networking hardware in the core. We can use this, but it's not so popular. It's not our priority to use layer 2 switches. Remember, layer 2 switches, they do not have a logical address or IP address for making logical decisions or for making routing decisions for the packets. Only layer 3 does, but layer 2 switches do not, okay, have that. The layer 2 switch, they don't have any, they don't make routing decisions, right? So that's why we don't prefer using layer 2 switches for the core segment of the 3-tier architecture. However, they still can be used, but it's not a preferable choice, okay? But is that okay? It's not a preferable choice. Now let's move on quickly. Let's talk about redundancy. Redundancy in the core segmentation of the 3-tier architecture. Redundancy is an important issue when we are designing campus network or we are designing an enterprise network. Okay, in the core segment, we must talk about or we must think about redundancy. We must find a way to solve the problem of redundancy. Okay, redundancy provides for a backup route. Okay, it provides us with a backup route whenever the network connection or in a network connection in case the link fail, in case there is a link failure. So redundancy will provide us a backup route. Remember, redundancy is to have a link that is inactive at the moment but can find its use when there is a failure in the busy route, okay? So this is a design concept, that something we put into consideration when we're designing the core segmentation of the 3-tier architecture of an entire network. Now the core hardware is typically interconnected with all the distribution network hardware. The core they are typically interconnected with the distribution. Now look at it. The core segments are connected with the distribution area. Okay. Now let's that brings us to the distribution or the aggregation layer. Distribution layers are also called the aggregation layer. Now this is the point where the individual local area networks are connected to the main campus network routers. So the point where the individual LAN, let's show that. I think we have the diagram. The point where the individual local area network, the individual LAN connects to the campus router. These points, they are called it's what we regard as the distribution. Okay, so from the LAN up to the router that we route it worldwide, it's called the distribution. It links to the distribution. Okay, so that's the distribution. Now in the distribution layer, what functionality is being carried out there? Routing of data packets is carried out using IP addresses, is carried out in the distribution layer. And also, what else is being done? Fixed-tree policies is carried out also. So routing of data packet and fixed-tree of this data packet, or the fixed-tree policies are being made in this distribution layer. Is that okay? And they are implemented here. This one do not have effect on the performance of the system. Okay, now let's go to the third layer, which is called the access or edge layer. The access or the edge layer, as you can call it, access layer or the edge layer. Look at it. Now this layer is this one, the entire one that we had highlighted here. This one is called the access. This one is called the access or the distribution layer. This one, okay, the access or distribution layer. Here the networking devices connects to the LAN, to the switches in the LAN. Is that okay? They connect to the switches in the LAN. Okay, so let's say we had networking devices in the local area network connects together here. They connect together. The network hardware used here are typically layer 2 switches. What we use in the access layer is layer 2 switches. Okay, Okay, because here they make use of the Ethernet addresses, or what you call the MAC addresses, to make routing decisions. Okay, not routing decisions, to make the decision for the which packet is being taken and the destination where the packet will be taken to. Okay, now we say here a switch is a better choice to use in this area, because here we'll be needed to deliver the packet to the different computer or the different destination. So it's better to use a switch that can make that we use what we call DC to make to forward the data packet directly to the distribution host. Okay, they will use their MAC address to make MAC address to make routing decision. Here in this access layer, a layer 2 switch is more desirable, because layer 2 switches can use the MAC address, the media access control address, to make their routing decision on where to deliver the data packets, okay, the destination where to deliver the data packets. So here it's more advisable to use a layer 2 switches. Is that okay? Layer 2 switch. Okay, so now let's talk about another characterization of what we experience in the design also, or we should put into consideration when we are designing a whole network system, including LAN and WAN, when we are considering a LAN and WAN configuration. Now is the traffic flow. Now let's give an example how a system can be from one LAN to another LAN in another place. Okay, let's assume a computer A1. A1 is from LAN A. Okay, B1, B2 are from LAN B, C1, C2 are from LAN C, D1, D2 are from LAN D. Okay, so now let's assume a computer A1 in LAN A sends a data to D1 in LAN D. This computer A1 in LAN A is sending a data to D1 in LAN D. Is sending a data to this one, D1 in LAN D, in local area network D. Okay, you can see from here, far end this way, could be another city, another country, or whatever. It sent the data all the way to this other side. Okay, now what will happen? The data is first sent through the switch in LAN A. You know that, right? So this data from A1 is first goes to this switch. You know, this is a switch. This is a switch. First goes to this switch, and then the data will first and foremost be sent through this switch in A1, LAN A, sorry, will first be sent through this switch in LAN A, right? Okay, and then to router A. From this switch, it will be sent to this router. Okay, the data packet will be sent to this router A. This is called router A. Okay, this is called router A in the distribution, and this router A is in where? Distribution. Is in the distribution layer. This router A is in where? The distribution A layer. The switch is in the access layer. So from the computer in the access layer, okay, from your computer or your networking device to the switch, then from the switch to the router in the distribution layer. Then from the distribution layer, what will happen? From the distribution layer, router A will then forward the data to the core switches. This router A will, from this distribution layer, router A will forward this data packet to the switches in the core, to the either switch A or switch B. You can decide to forward to any of them. You can forward to any of the switches. Okay, any of the switch. You can forward to switch A or switch B. You see from here, if it goes this way, it comes to where? Switch A in the core layer of the segment. In the core layer of the segment. If you decide to route it this way, through this way, if you decide to route it through this way, then you see it's going to switch B. It's going to switch B. It's going to. So it depends on which route the data packet follows. If you route it through here, it goes to switch A, and if you route it through this place, it goes to switch B. Okay, but it's okay whichever switches this data packet is sent to. There's no problem about that. Okay, there's no problem. Then switch A or switch B then forwards the data to router C. Now from switch A, the data connects to router C. From this switch A, how do we arrive at C through this place, through this gateway. From this switch A, this layer 3 switch, the data comes through here. Is it through here? Yeah, through here. Look at it. Through here, through here, through here, then to router C. So if the packet was sent to switch A, it's going to follow this route and be forwarded to router C. Right? It's going to come here and be forwarded to router C. Is that okay? We say the data packet, router A, then forward the data packet to the core switches. We've already established that. Then switch A or switch B, they forward the data packet to router C. Now, we've shown how from switch A, the data packet is forwarded to router C. Now, what if the data was forwarded to switch B? How does it get to router C? Just through here, through this gateway. Okay, from here, it comes to router C straight away. So router C receives the data packet, right? Now the data packet is then sent to the distribution host in LAN D. See, it's sent from this router to where? To the distribution host in this switch in LAN D. So it's sent here. The data packet is sent here. So when it gets here, the switch here, remember they use layer 2 switch. They are layer 2 switches. This layer 2 switch, from the data packet, it will read the MAC address of the destination, and then we send it to computer D1 in the LAN D. We send it to computer D1 in LAN D. Is that okay? So this is how we forward this thing in. So see, from here, first of all, to this LAN, to this switch. This switch we send it to forward it to this router. Then this router we send to layer 3. The core switch, layer 3 switches in the core. Layer 3 switches will forward to router C. Router C will send it to this LAN D. LAN D will forward it to the destination computer. So that's what is taking place in the entire network. That includes LAN and WAN. That includes local area network and wide area network. Is that okay? Now let's move on. Now let's talk about the data center. What happens? How the message is being sent through the data center, because this message goes through the data center. Now the data center houses the critical enterprise server. That's where you have the critical server and your storage. Okay, every campus have a data center, and every big enterprise has a data center. So in this place, this is where the data are moving from and to the server constantly and continuously. So the data are always going to the server, coming out from the server, going to the destination, and so on and so forth. So here, when you are designing this, it requires a design that can optimize such flow with a great speed. So you can see this design must be able to optimize this concept, because there's a front and back transmission of data coming and going. So the design must optimize, put this into concept. Okay, now let's take a look still on the data center architecture. Instead of using the three-tier the architecture, okay, the data center does not use the three-tier architecture. In itself, it uses what we call the spine and leaf, which is a two-tier architecture. The data center itself doesn't use the three-tier that we described. It uses a two-tier architecture, which is called the spine and leaf layers, which has or contains the spine and leaf layers. Okay, now let's take a look at an example that shows that. Now the leaf layer in the data center has different servers. Each server racks will have one or more access or edge switches. Each of the rack has different racks, okay, has different segmentation. Each of the segmentation has access to the switches, okay, and these switches are fixed with top of rack, what we call the top of rack, TOR. They are fixed. These switches are fixed with top of racks, and they connect to the servers within the racks and aggregate traffic from the server. They connect to the server within the rack, and they also aggregate traffic. Okay, they aggregate traffic from the server. That's the leaf. Now, still on the leaf layer, the leaf layer is then connected to the spine layer, obviously. After the leaf connection, there we go to the spine layer in the data center. Okay, the spine layer is the backbone of the network in this regard. Remember, in the three-tier layer, we say the core is the backbone. But in the two-tier layer for the data center, we say the spine is the backbone of the entire system. Are you with me? Okay, good. Now let's move on to the next thing. Now let's talk about the high-speed serial connection that comes with that has to come with the data center. The data center. The term high speed is very relative, because for a large enterprise network, what you call high speed is different from what you call high speed for a small network. Okay, for a campus network, a very large campus network, the high speed of data is different from what you call high speed for a small office space network. Is that okay? So a high-speed connection could be a DS3 line, which uses a speed of 44.7 and more megabit per second, and a connection to a high-speed serial interface, HSSI, high-speed serial interface, okay, which support data rate from 300 kilobit per second to 52 megabit per second. Remember, for this 44.7 megabit per second, okay, is within this range of 52 megabit per second. Okay, so it starts with a small speed of 300 kilobit per second for high speed, okay, or a huge network, to up to 54 megabit per second. Now, in case of a small network, a high speed serial connection could be maybe using a tier 1 line, which is just 1.544 megabit per second. You can see this speed is small, relatively small compared to 52 megabit per second. So comparing 1.544 megabit per second is relatively small for 52 megabit per second. So when you have a small office space, 1.544 megabit per second could be okay for you, and you just use a tier 1 line is enough for you, okay, for a small office space. Now let's talk about the data channels through which this data passes through. The most common communication data rates for edge users are the DS0, DS3 up to DS0, DS1, DS2 up to DS3, and then and also tier 1 to tier 3. These are just manufacturers specification. They are the same thing. DS0 to DS3 same as T1 to T3 in this regard for channels. Okay, the T1 or DS1 and T3 DS3, they are just different designations that are normally used. They handle the same data rate. Okay, and they are just used interchangeably. Okay, now let's talk about data channels. The data channels with our data centers. Okay, the data channels. The DS0 designation is for the base rate of the digital signal lines, just for the base rate, okay, of the DS0 for base rate, okay, of the digital signal line. Basically, the data rate of a digital telephone, okay, this one we normally use it for a digital telephone. Now let's take a look at the designation and the data rate. For DS0, you use 64 kilobit per second up to 56. Within 56 to 64, okay. Then for TS1 or T1 or DS1, we use 1.54 megabit per second. T2 or DS2, we use 6.312 megabit per second. T3 or DS3, we use 44.736 megabit per second. When you're not using T4 or DS4, you use a very high speed data rate, transfer rate of 274.176 megabit per second. Is that okay? Now let's move on. Now let's talk about some telecommunication service provider or data that provide this kind of arrangement. Data lines are leased from telecommunication carrier, okay, like Telco. Telco is a telecommunication carrier, okay, like Globacom, like MTN, okay, like 3 in UK, like Celcom in Malaysia, like Deji in Malaysia, like Mazis in Malaysia, Okay, so these are like telco in United States, in USA. Okay, telco in USA. Okay, these are what? Telecommunication service provider. Okay, we say data lines are leased from the telecommunication carriers, and they carry any type of data. Your data, whether it's voice data, they can carry it. Whether it's data, whether it's voice, is data, or it's video, they can. This telecommunication outlet or outfit can carry any type of data, voice data and video. They can carry. Now, also, this telecommunication carrier, they don't provide you with your own point-to-point private physical connection. They don't give you point-to-point private physical connection. The telecommunication carrier provides you with sufficient data bandwidth. They give you a bandwidth. Okay, they give you a data bandwidth and a switch connection in its system. So they switch you to connection and give you a bandwidth to carry your data traffic to your destination. That's what they do. They don't give you point-to-point connections, physical connections. They just switch you to connections, and they'll give you a bandwidth to carry your data. Is that okay? To your destination locations. Now, most likely your data will be multiplexed with hundreds of other T1 or DS1 data channels. So you know the meaning of multiplexing, right? We did it in a digital system. We did multiplexing digital system last semester. So multiplexing is putting multiple data channel to pass through one channel. Okay, bringing them, finding a way to make them suitable to pass through one. Now, telco cloud. Here is a telco cloud. You can see the cloud. This is a telecommunication provider. You have network X, network Y, network B, network W, network Z, network A, and so on and so forth. So all of them, they access this telco cloud where their data will be carried. Okay, these telecommunication carriers, they switch network used to transport data to destination. That's what they do. They just switch to the destination area due to the IP addresses that has been provided by the routers. Okay, that will be dynamically assigned by the routers. Okay, and then also the interconnected network on the internet. Okay, all the interconnected network on the internet. That's what they do. Now, point of presence. The point where the customer connects the network data traffic to the telecommunication carrier is called the point of presence. The point where you as a customer connects your data traffic to the telecommunication carrier is called the point of presence. Now, line of demarcation. These are terminologies used with this. Line of demarcation is the point where the ownership of the telecommunication equipment changes from the telecommunication carrier to the user. Your line of presence is the point where the ownership of the telecommunication equipment changes from the telecommunication carrier to the user. That's what we call the line of demarcation. Okay, then the CSU DSU. Remember, in your router you have the CSU DSU unit, right? The CSU is the channel service unit and DSU is data service unit. A telecommunication carrier requires that a data connection be made through a channel service unit. So it is from this your channel service unit that you can connect to the telecommunication carrier to carry your data, whatever type of data you have, whether it's a file data, whether it's a video data, whether it's a voice data. So they will connect from your channel service unit, or what you also call the data service unit, from your router. Okay, from your router to the telecommunication carrier, where they will carry and route your data to destination location, where they will route your data to the destination location provided by your hardware interface, that has been provided by your hardware interface. First of all, they will route it to your router decision that has been made by your router, and then deliver to the network or the particular networking devices on that network based on the MAC address in the layer 2 switching in that segmentation. Now let's talk about the Metro Optical Ethernet, which is a fast speed carrier. The Metro Optical Ethernet or Carrier Ethernet. The Metro Ethernet is an extension of the Ethernet infrastructure. The extension of Ethernet infrastructure via optical technology beyond the Ethernet network infrastructure. So Metro is using the Ethernet infrastructure using optical technology beyond the Ethernet network infrastructure. Carrier Ethernet is an extension of the Ethernet infrastructure that covers much more than just the metropolitan area, maybe the wide area. Okay, Carrier Ethernet it's used to carry your data from your data service unit or your channel service unit by the telecommunication carrier to the wider world. Is that okay? While the metro is to cover your metropolitan area, maybe within the cities or to the nearest cities. Okay, now let's move on quickly for the sake of time. Then we have what we call the Ethernet service type. The Ethernet service type is like a service that provides a point-to-point Ethernet virtual connection. What we call the Ethernet virtual connection. Point-to-point Ethernet virtual. This is what we call between two user network interface. Between two user, for example, this user network interface may be in, let's say, which city? Let's say one city. Let's say in Africa, which city can we use? In Malaysia, okay. Let's say in Malaysia, let's say Berui, Kuala Lumpur, and Johor Bahru. Okay, so in Kuala Lumpur, this thing has what we call the user network interface. The router has the user network interface, which helps to send this data over via the point-to-point EVC. EVC is your Ethernet virtual connection. This is your point-to-point Ethernet virtual connection, meaning there is no wire. It's through electromagnetic wave. So carry this one to the other side that has the equipment to receive it and bring it to the network. So this one is wide area service. Is that okay? So Ethernet services are used to provide point-to-point Ethernet virtual connections. That's the point we are making. Now let's go to service attributes. In service attribute, we have different segmentation that we need to describe. One is the CIR, the committed information rate. The committed information rate is the same parameter used in frame relay. Okay, it's used to guarantee the bandwidth the network must deliver. So this committed information rate is to guarantee the bandwidth that a network will deliver. It is the average rate measured in bit per second. Okay, the average rate. Okay, measured in bit per second. Now let's still on service attributes. Let's look at what we call committed burst size. The committed burst size is the traffic size that is allowed to burst. Okay, the traffic size that is allowed to burst. It is not discounted or shaped by the profile. The traffic size that is allowed to burst. Now the committed burst size is measured in kilobyte. Let's move on for the sake of time. Now still on the service attribute, let's talk about what we call the EIR, the SS information rate. SS information rate is an average rate parameter in bit per second. Used for what? Used to allow traffic that is greater than the committed information rate to traverse and may be delivered or may deliver it when the network is not congested. Okay, so what this does is SS information rate is it helps to, if there is a traffic that is greater than the committed information that is supposed to go through, to be sent back. When the channel is less busy, then it will come again to pass through and be delivered. Now we have still on the service attributes with the network. we talk about EBS, which is the SS bus size. SS bus size is the bus table size allowed when the traffic is in the EIR, the SS information rate. When the traffic is in SS information rate, the bus table size, what size of traffic can be sent back, and when the channel is less busy, then that service, that size or that packet can come back to pass through the channel. That's what we call the EBS, SS bus size. Okay, the VLAN tag. Now let's talk about VLAN. We finished all the service attributes. Now let's talk about the VLAN, virtual local area network tag. Okay. Now just now you can see we saw that here over this place there we have point-to-point EVC, Ethernet virtual connection here. There was no wiring within this place. It's a worldwide. Okay, there was no wiring. Now let's take a look at the VLAN tag, what the virtual connection is all about. When connecting multiple campuses across the wide area network, when you're connecting different campuses or different branches of campuses among wide area network or virtual local area network, cannot be extended. Okay, the virtual area network, the VLAN, cannot be extended. Okay, cannot be extended when you are connecting multiple campuses. The separation has to be done at the higher OSI layer. At the higher OSI layer, you have to do a separation of this. Now it's typically carried out as a different routed network. Okay, this one is carried out as a different routed network entirely. Now with a carrier Ethernet network, local area network extension is no longer an issue. With the carrier Ethernet network, the local area extension is no longer an issue, right? Because we can carry it over a wireless interface or wireless podium. Now the VLAN tag presentation, the VLAN tag preservation service attribute can be used to carry out the mission. Is that okay? Can be used to carry out the mission. Okay, so we also said that this attribute, or with this attribute, all the Ethernet frame received from a subscriber transverse or touched across the EVC. EVC is Ethernet virtual connection. They will transverse. Okay, they will be able to go through. Is that okay? So with this, we've come to the end of this. Remember, we've talked about higher service, this interface. We've talked about HSSI. We talked about optical carrier. We talked about DS, direct service line from 0 to 3, and T1, telecommunication line 1 to 3. Okay, we talk about DS. We talk about telco as an example as a telecommunication carrier. We talk about telco cloud. We looked at multiplexed. Okay, so with this we've come to the end. Okay, we also talk about point of presence. We talk about line of demarcation, CSU, DSU. We talked about HGSC, PPP. Talking about metro optical Ethernet, MOE. Talking about carrier Ethernet, and so on and so forth. Okay, we also talk about the metro Ethernet forum. We talk about user network interface, UNI. We talk about Ethernet service. Then we talk about the Ethernet virtual connection. We talked about ELAN, that's Ethernet local area network service and type of ELAN. We talk about E3 service and so on and so forth. Okay, so with this we come to the end of this section. Thank you very much for being with us.